Hi students, I thought that I'd take about 10 or 15 minutes to go through these three exercises described here. And really, don't you guys love Andy Field? He's such a crack up. Okay, let's take this first one. It is bladder control. And basically the question being asked is, do people make, looks like, do they make hastier decisions, or do they make decisions to receive a small financial reward quickly or a large financial reward later, depending on how much they need to pee? So with all these things, you just find the data set there, and then you should have, like I do, all of Field's data sets. And let's see here. It was Tuck et al. Double click it, and that brings up our SPSS. And just go back for a second. So the thing that he wants us to do is do an independent samples t-test on these two different groups. The group with the full bladder versus the group without the full bladder. So high urgency and low urgency. On the question of number of long-term rewards chosen out of 8. So this is an independent samples t-test. So you go to Analyze, Compare Means, Independent samples t-test. The drink condition is the grouping variable, and then the number of long-term rewards is a test variable. And just remember that when you're doing a t-test, you've got to define the groups. They are 1 and 2 in this situation. I say continue and OK. That gives us our output. And if we look at the output, we see that those who have a full bladder choose 4.5 out of 8. And those with a low urgency choose 3.8. So that mean does look different. Remember that the first step when you're interpreting a t-test is to look right here to see if Levine's test for equality of variances is significant. If this number is more than 0.05, which is this one is, then you look at equal variances assumed to get to the t-value, which is 2.203, and the significance is 0.03, which is less than 0.05, so we reject the null, and what we arrive at is there's a significant difference between the groups in terms of the number of LL rewards chosen. Okay, that was that. And people are asked, some people have asked, what do I want you to do exactly? Just take a screenshot of this to show that you've done the analysis. That's sufficient. Okay. All right, we're done with that one. Then here comes the next one. In this situation, we're comparing two means again, but we're comparing repeated measures. It just means that we're looking at the same subject across two different measures. So it's called a paired samples t-test. In this situation, it's actually, I found this a little convoluted, but they counted how many male and female children these 50 most beautiful celebrities had. And so obviously it's paired because they're counting how many male and female children each of these 50 celebrities had. And this is the Gelman and Weekleem study. So we go up to Gelman and Weekleem, double click it, it brings up our SPSS. it is. So now we have our 50 people, 50 attractive people. Wait, that's way more than 50. Oh, maybe. Oh, 274. So yeah, that's a lot of celebrities. I guess it must have been over a few years that they looked at the 50 most attractive celebrities. In any case, what we're asked to do is just to compare a t-test looking at is there a significant difference between the number of sons and the number of daughters had by these beautiful people. So we go to Analyze and compare means again, and this time we go to the paired samples t-test. Click on it. And number of sons is variable 1, and number of daughters is variable 2. It's as easy as that. And then we click on OK. And what we find is that there is no significant difference because that number is greater than 0.05. So the average number of sons is 0.68. The average number of daughters is 0.62. Very similar means. And so it's not surprising that there's no significant difference. And that's that one. All right, now we get to my favorite one because it's so crazy. Which is called Scraping the Barrel. And so the question is, why is the human penis shaped the way it is with the bell end? And some researchers thought that it had to do with scooping out the semen left by other males so that you would be the one to impregnate the female if your penis was good at getting rid of the other guy's sperm. So they did this thing, which it is pretty gross, where they filled up a fake vagina with cornstarch and water, and then they had these like 3 kinds of sex toys. Basically, one that had no bell end, and one with a big coronal ridge, and one with a minimal coronal ridge. Okay, and so the question that he wants to answer is there a significant difference between these 3 phallus shapes in how much sperm they displace? The study is Gallup, so I go to the Gallup data set. Where are you? Bring up my SPSS. And now he suggested doing a graph, which is fine with me. It's not a bad idea at all. Using a box plot. So you just drag and drop that box plot. And then the phallus type goes down here. There are 3 of them. No coronal ridge, minimal coronal ridge, and coronal ridge. And then on the y-axis, how much semen did they displace? And then hit OK. And that gives you this box plot, which doesn't look too good. But and he actually edited it. And it's not a big part of the class to edit it, but just so you know, you can monkey around with this so that it looks a little bit better. But all you have to do is eyeball this to see, obviously, when there's no coronal ridge, it displaces less than 40% of the semen, and with a coronal ridge, you're looking at 80% or more semen displacement. So when we do an ANOVA, we're going to compare these 3 groups and see if there's a significant difference. But even more so, we want to see where is that difference. Now, when I've taught you guys about how to run an ANOVA, I did post hoc testing and suggested that you guys should select Tukey's. He is doing a slightly different thing, these planned comparisons. Let's see how I put it here. Yeah. So, oh, these like contrasts, he calls them. So I'll show you how to do it. It's actually very easy to do. Okay, so we go over here. We say analyze. We're on compare means, and we go to one-way ANOVA. And the factor is going to be phallus type still. Now notice we don't need to define the groups because an ANOVA is more than two groups, so you don't need to define what they are. And then Seaman displacement on the dependent list. Now for contrasts, what we do is we say, okay, the first one is going to be -2 and 1 and 1. So what that does is it sets the first thing apart from the other two and gives those equal weight. And then, so that's the first contrast. Then for the next contrast, let's see, how does he set it up? Oh. He sets it up as 0, -1, and 1. Where am I? Okay. So we have 0, -1, and 1. So you can see that this will compare the two phallus types that have some kind of coronal ridge against each other. And this one is given no weight at all. Okay, continue. And then he suggests these options. I like the descriptives. He didn't say to do that, but I'm telling you I like it. And then he puts these in. I'm not teaching you guys about this stuff, so don't worry about that too much. But anyway, we'll just follow his suggestions and hit OK. All right, so then the first thing is where's Levine's test? Here it is. Levine's homogeneity variances is not significant. So that just means that's good news. It means that the variances are not significantly different between these three groups. This is the number that you want to look at where you can see the difference between groups is significant. And that shouldn't surprise us. If we look at mean Seaman displacement, it's 35% with no coronal ridge and 91% for the minimal coronal ridge or the coronal ridge. So in both those cases, it was a 91% displacement. Okay. So then we get to these contrasts, and contrast 1, remember, compared this no coronal ridge condition to these two. It was 2 and or -2 here, and then 1 and 1 here. So in that contrast, it is significant. No surprise, right? And then the other contrast set no coronal ridge to 0, kind of took it out of the equation and gave this -1 and this 1. And so basically you're comparing these two. Would you expect that to be significant? Absolutely not. And what we find is it's definitely not significant because what you have here is greater than 0.05. Okay, that's it. That's the 3 assignments for the week. I hope you enjoyed running those analyses.